Begin recording. I wanted to take a moment to call out the things that we've laid before you in Module 2 first. Within Module 2, this retake is in place, and it needs to be complete by 11:59 p.m. Saturday. Now that is this Saturday. So what you want to do, having reconciled your errors, you want to review your reconciliation and then retake this. There's a little less time, and the questions have been tweaked a bit for variability and challenge. So that's one thing that's in place. In our coding and database essentials, you had 3 assignments up to this point: VirtualBox, CS Dojo, and custom functions. We want a light touch. We want a modest exposure to the world, the wonderful world of databases. In Module 2, you experienced the automation and power of iterative calculations that you can quickly work up in the Excel environment, and how you can use repeating formulas with absolute references to make quick work of a fill down so that you can duplicate thousands of variations of the same kind of thing. And this is a very important principle that you're going to see in following modules when it comes to generating random data or sample data or typical data, where you want certain parameters to be in the mix. Speaking of data, one of the powerful things about databases is that they can import or suck in data files or text files, and they can make quick work of an import. And what I've done is created a very basic, now the recording here is pretty primitive. So full disclosure, when you click on this, you'll notice a little clicking noise in the background. This is before I had better microphone and so on. But the basic steps to follow are very straightforward, very quick and easy. And essentially all we're doing is creating a couple of quick tables. When you follow this YouTube video, the resolution is older school. It's not quite up to speed as far as high res. So when you try to figure out what's going on the screen, I've also included screenshots to follow the basic build of the database, right? There are 3 points for this solution. So it's kind of like a mini solution, and it's intended to complement some of your programming activities, okay? So what we're going to do is put this in front of you, and you'll notice that I want you to have this done by 3 p.m. Thursday, as in this Thursday, because it's, you know, it's 48 hours and it's a quick walkthrough, and you can do this in under an hour, basically, right? So what I want you to do is to go ahead and work this up. Now, at the same time, I'll tell you what, at the same time, what we want you to do is to take a look at your calendar. I may push this back to like Monday noon or start of next class. I know that the final attempt of your Module 2 assessment is due no later than this Friday. We wanted you to try to take a first crack at this. I think what we'll do is we'll bump this back a bit. How about start of class this time next week? Does that sound good?
Yep, that works.
Yeah, that works.
This is all right. So I'm going to go ahead and edit this right now. And
I have a question. You said that the questions would be modded for the reconciliation. Isn't the reconciliation us just you know, making like taking the proper answer for that assessment? Why would the questions be changed?
It's, okay, so your question had to do with the reconciliation, right?
Mhm.
The reason you'd want to refresh the trail with the reconciliation is because some students submitted the reconciliation promptly, right after their first attempt. Others took a while to get around to it. It's been some days since people recalled or refreshed the mistakes they made on their first attempt. The reason I was suggesting that you take a fresh look at your reconciliation before the final attempt is just to ensure that you know, those things haven't been forgotten in. And sometimes we're in a hurry and we're in a dash to get things submitted before the deadline. So it's just a good idea. You have your first attempt and you have your reconciliation. And between those two, if you glance through that stuff before you make your final attempt, that should help quite a bit. Does that answer your question?
Yes.
Okay. All righty. So yeah, I'm going to go ahead and let me just run this back a bit. So we'll actually put this at the top of the list by the end of this week so that everybody should be ready by Thursday. Everybody should be ready to do this. So by the time we start class on Thursday, we'll review this detail and we'll slide the 3.5 assessment to the top of the list so it's easier to get to, okay? Let me change the date now here as well. I said 2, it's 1 November actually. The day after Halloween, yeah. So day after Halloween, I'll change that to read 1 November. So when you are working to prepare for the Module 3 first attempt, your first attempt of the Module 3 assessment, and it's a good idea to work through this database option. One of the references inside the references folder has been revised and updated, the addendum in particular. It's going to be important for you to make sure that if you downloaded a copy of the Module 3 Study Guide addendum, that that you would delete any previous versions you have. Now, the study guide itself hasn't changed, but essentially, it's important to make sure you have the latest and up-to-date version of the addendum. And that said, what I'd like to do is pop into the addendum very briefly, and I'd like to walk through some other examples of database tables or data sets. We've taken a look at other examples in the study guide and in slides, auctions, whale databases, and so on. And here you have 3 sets of data, 3 data tables: customers, orders, payment information. And so if you were to create a basic database for a business that had sales, just common retail sales, right? Customers would order things, they would pay with specific kinds of instruments, right? So you'd have payment information, you'd have the items that were ordered, and you'd have information about your customers. In order to organize this in the most efficient manner, you're going to create a join between tables where you can identify unique values and where they are repeated in other tables. And in that manner, you don't have to duplicate or replicate information. What am I saying? If this were an Excel spreadsheet right now, and we wanted to track our customer orders and payments, we would basically have a huge spreadsheet. And for each row, we'd have information every single time about our customer. There might be an auto incrementing number, but we'd have a first name, middle name, last name, date of birth, address, telephone, and so on. The things that you need in order to successfully process a payment card. What am I saying? Well, if you don't have the other information correct, you can't use a credit card, right? Everybody's familiar with this concept, yeah? Kind of, sort of, maybe?
Yeah, so you're basically just saying that everything works in tandem with each other to be able to activate all the others.
Correct. We have a relationship between the customer number in the customer's table and the customer number that's referenced in the orders table. T for table for orders, T for payment information. Now, what are we saying? We're saying that so long as we have a join between the customer's table and the orders table, everybody can see my gestures, yeah? A very wealthy customer could place infinite number of orders. That's what that symbol means, right? So there's one for each one customer. Depending on the money they have, they could do several, many, or an infinite number of orders. And the simple truth is, with this join or relationship in place, I don't have to repeat this information over and over and over again for each order. I can simply access what's in this table for that given customer at that given row. A row in a table is called a tuple, or a row in a data table is often referred to as a record, a database record. Now, each of the headers at the top of the table, the columns coming down, like in a spreadsheet, those would be called fields, okay? And it's important to understand that you have, wherever you have unique values in one of the primary fields, right? We call that a primary key. This number is the key to a relationship between tables, right? So this is referred to as the primary key of the T customers table, and correspondingly, we have a customer ID over here. So the ID number, right, looks a little different in terms of how the field is named, but the concept is the same. If I have a customer number over here and I have a customer ID in the orders table, this customer ID can be listed many times depending on the number of orders. Now, the thing to remember is this would be the foreign key or external key. So I have a primary key, and then I have a foreign key. The foreign key is the other side of the bridge or link to another table. Are there any questions about what I've just explained?
No, sir.
Now, in the orders table, it's the order number that's unique. And the order number references the customer ID, the order date, the cost, the tax, the shipping, the total, and the payment ID number. It's the payment information table that has a payment ID number, right? So what I'm telling you is this gets pretty interesting pretty quickly. If I zoom out a bit, I have a relationship, just to recap, between customer number and customer ID in the T orders table, okay? This is the primary and the foreign key between those two, and we have a join or a relationship established, a one-to-many relationship established between those two tables. By the same token, we have a customer number reference here, and if we follow this over, on the other side, we have the customer ID number again in the payment information, right? Now, for all intent and purposes, we could swing this entire table right here. Let me show you. We could take this table, and just to keep things a little less tangled, we could swing it over on this side of the T customers table. And then that way you could see the customer number between customers and orders. And on the left side, you could see customer number in the customer table and the other side. Now, what am I getting at? If I swing this whole table to the other side, what you will find is that you have those two joins between customers in this direction and customers in the other direction to payment information. And that kind of puts the customers table in a position we call monkey in the middle, right? So it's an intermediate table, but it joins the data from this table and from this table. So the two tables are linked. These two tables together are linked, but they're linked through or by virtue of the two relationships, two individual separate relationships in the customers table. Does everyone understand what I'm talking about? Maybe not. Okay. In your coding solution, you're going to see this. And so basically, if we open this up, and what I'm going to do here is kind of increase this, you'll import some information, and you'll follow along with the video, and you'll name the tables in a specific manner, right? For sightings and species lookup. And essentially what will happen is you'll get a chance to relate the tables once there's information in them. So there's going to be information imported. We're going to use the external data feature here in Microsoft Access. Notice the reference to primary key, right? The turtle species ID is an auto number, whole number, unique for every turtle species. It's the primary key for this sightings table. Then we have a species lookup table, right? Now, what do we do with these things? In the Design tab of Microsoft Access, when you click that, you get a chance to add the sightings table and add the species lookup table. And the moment you do this, it's going to start tingling. Now, you don't see the tingle on the screen. It's kind of a back-end magical sort of tingle. And I know that's an oversimplification, but basically what we've done is created an environment here on the design screen. So you click design, and then over on the right, there's a way to add the tables. There's an option to add the tables, and you'll see that, right? The images that you see on the prompts may be a little different because the version of Access is a little different, but essentially it's the same thing. You're going to go into the relationships, edit relationships option, and then add the sightings table and the species lookup table. Please do not send me an email and say, my screen looks different. I'm going to say, yeah, let's see. In our recording around the 30-minute mark, we talked about how it's going to look a little different because it's a different version, but it's pretty much the same. So take a step forward in faith, right? You go to the edit relationships option. Ooh, I almost said something naughty there. And once you do, you're going to drag from the place where the value is unique and special, the primary key, and you're going to drag that field on top of the other field. Here, it's the sighting ID that's unique. If I'm looking at turtles, I'm going to have a set of turtle entries based on species and name. Over here, I'm going to have a set of sightings where I saw them. And I'll be able to tell when did I see them, the name of the turtle, the species ID, and the observer name. Now, this is a very simple database, very simple database. But the point we want to do, the activity is designed to give you a chance to crawl before you walk and run. So you're going to drag from here where the species lookup table is shown, and you're going to take your mouse and click it and hold the mouse button down and then drag it up and drop it right here on turtle species. When you do, this thing is going to come up. And you can check this one and this one. Check this box and this box. What that will do is it will establish the one-to-many option, right? And if you want, you can click into the join type to see what kind of join this is, right, between the two tables. So that's pretty cool. Once that relationship is established, then you can do pretty interesting things, okay? At that point, you can create an instance where you stitch the two tables together with something called a query. Now, further on down in your review, we're actually going to establish a simple query and then show you how to combine the fields from each of those two tables into this screen. You just drag them and drop them, right? So in a query, what you're doing is showing the tables again, and you're saying, okay, from this table, because they're related, I want to see this field and that field and the other field. Oh, and in the second field, I want to see this and that and the other. And because they're joined, when you run this, it'll create a stitched together version of the tables. In other words, the query will combine the information from both tables. That's where the word join starts to come into play, right? So in this case, I entered notional names. Please feel free to use whatever names you'd care to. And I would prefer that you name your turtles something other, please, because, you know, every now and then we have students that are in a hurry and they grab like this picture and they turn it in like their own. And I'm like, really? So you built this database in October of 2022, but what year is showing and which version of database? It's like, it gets really awkward very quick, right? Instead of George, Lucy, and Volkswagen is a leatherback, by the way, a leatherback turtle that is as large as a Volkswagen Beetle, right? The point is I want you to do something creative with your names. And as you work this process, what you're going to find out is that you can use wizards to combine these tables and create more queries to get some very interesting information. Again, this may seem like a lot, and it may seem like a long time, but if you follow along and watch the video first, and then open, please, everyone, watch the video first, yeah? And then go back and look at the screenshots and have that open in a PDF viewer, not this PDF viewer, the other PDF viewer, the screenshots, have those open. That was over on this tab, I think. No, it was on this tab, I think. There we go. Yeah, have the PDF open, and then just by looking at the different screens, you're like, okay, I remember this. Okay, I don't. Oh, snap, right? Well, so then you can go back to the video and kind of hone in on a certain place. That's what I would recommend. I would also recommend that you do not attempt to complete this short, very efficient, delightful little introduction to the wonderful world of databases when you're multitasking and doing 3 other things. Because it's simple, kind of like riding a tricycle. But have you ever watched a toddler get on a tricycle and they start pedaling too fast and they're distracted and they're looking all around them and they turn the wheel, torque the wheel too much, they're not paying attention? What happens? What happens? Yeah, they lose control, right? And unless somebody's watching them, it's like boom, and then it's very negative, right? And we don't want this to be negative. So if you give this a wing it, now you may have a different way that you can work that's far more efficient. And please, by all means, don't let me stop you. But what have I done to make this easy? And why am I saying this is short and sweet? I've built an observers table and a turtles table. And I ask you to use your own turtles names, right? So what are you going to do after you download this turtles table? You're going to notice that when you click on it, this is probably going to happen. I mean, you might be able to download it You might, can we download this thing into a text file? Let me see if I can download. Can I download this by right clicking it? No.
It's save link as.
Save link as. Oh, and that would do it. Okay, beautiful.
I've got experience with Access because of my job.
Okay, I want
When I
to,
worked with Castle, they made me do stuff like this.
yeah, depending on the client, depending on the consumer technology that you're using and how easy it is to do things like right click. I just want to check and see, first of all, if we're dealing with, are we dealing with, there's the test. Oh yeah, yeah it is. Okay. So what you have here is, now there, again, there are going to be some differences between the examples and what you have. But if I go into observers, right, those are the observers. You can change the names of the observers and you can change the name of the turtles. And yes, I did that because, so here you see leatherback green, and then you see the genus species name. In your database, you don't have to type all that in, okay? But you import it. And so if you run into a snag where it's like, hey, the screen is so different, the version has changed, and what I'm following just doesn't make any sense at all, then shoot me an email. And if you're the first to shoot me an email where you've encountered something that would likely trip up the other students, I'm going to post a bounty, a little additional credit in the additional credit column for you and the courtesy of your notice. But you're going to see this kind of thing all the time. Now, I just want to take a moment to talk about this. We've already experienced with our CS Dojo that there are differences between the screens we're working with and the screens that they're showing here and there along the way. And this is just one of those common realities of computer applications, especially scientific computer applications, especially when the versions change. It's a common thing. But the goal is to keep, it's like, what would you do if you were dropped into a strange neighborhood and you knew you were close? You'd start looking for landmarks, right? You'd start looking for, and so I do realize that there's a certain frustration level, but I want you to develop a strong habit to explore a little on your own. I am willing to assist. I am willing to assist no matter. And there could be differences in your client in your laptop or your PC where the version or the screen is just looking different. And I get that it's, you know, it's not there like your video. No problem. I'm ready to help out. But I do value the idea that some of this stuff, as we go along, there are going to be a lot of changes out in the references online for how to do a thing, and there will be subtle differences. And the more you're used to subtle differences, the more comfortable you'll feel when you encounter them. They won't slow you down or halt your progress. It's a bit like learning to breathe when you're swimming in the water. You get a few mouthfuls of water when you first start to learn to breathe when you're swimming in the water. For those of you that don't swim at all, I'm sorry, that's a bad analogy, but basically what I'd like you to do is to kind of see it through and have a look and investigate a little bit. I don't mind helping, but I don't know if it's the full moon a couple of weeks ago or what's going on, or there are other uncertainties in our world right now, but lately I have been getting some requests for support, and then students are apologizing because there it is, and it's, oh, how did I miss that? And the other thing I'd like to add on the flip side of the coin is no one needs to apologize. Okay, if you were in there and you were in a hurry and it wasn't showing and it wasn't clear, and now it is, I'll take the win, and you should feel good about it too. So So please avail yourself to assistance. If we run into a case where it was something that was, obvious, don't feel bad, right? But before everybody starts pulling the chain, because it's like, oh, this is different, that's different. Oh, what? Try to read on, watch the rest of the video, check out some details on the screen. Yes, there are going to be differences, and see how far you can go. Again, if you find something that's a total disconnect, I will post generous additional credit for your discovery if you're the first to email me a screenshot. Are there any questions about the 3.4 solution before we turn you loose early? Why are we turning you loose early? We need you to try to engage your first attempt at the Module 3 assessment. We need you to complete your Module 2 final attempt, right? And there are a few students here and there that are still slugging it out in the lower assignments. And what I'd like to do is just close out for the day. Now, that reminds me, there is one more thing. I showed you this. I do want to show you the addendum. In particular, there is some very specific information about databases. And if you have not dove in yet, it's really important for you to spend some time. Now, the word codify means to go ahead and you create a framework of understanding. When you codify things like you codify the hurricane events, so you're categorizing and you're analyzing and you're sorting. The word to codify something means you're studying it meticulously. Now, I'm not Webster's dictionary, but basically it's really odd that COD was the first to codify a database. Now, if you didn't catch me the last time I pulled that pun, I just think that it's amazing. And the Turing Award is the equivalent of the Nobel Peace Prize for computer science. Let's say that again. There's only a handful of people in the world that have ever won a Turing Award. But COD, the one who defined how tables can be related with relational database, is one of them, right? And then there were some that followed in their footsteps. That's when you get into data science and all that cool stuff, right? So I mentioned some examples. Forgive me if you have taken the time to look at the addendum, but I wanted to call this stuff out formally before you wing yourself into the first attempt of the Module 3. Here we're talking about database normalization. Normalization is, and I need to talk about this a moment, when you have data sets and you want to organize them into the least and most compact tables where information is not duplicated needlessly, that's called database normalization. We're breaking down data sets into the smallest possible tables. Let's repeat that. When we normalize databases, we are saying, hey, I want to break this information down into its lowest, simplest, less repetitive format. And then I'm going to stitch the tables together, and that's where the magic happens. The first step is to normalize the database. So what you want to do is look for cases where information is duplicated. What am I saying? If you have something that looks like an Excel spreadsheet where you're seeing the same stuff over and over and over again, you don't have normalized tables. But if you organize the information that you're going to manage with a database so that logically speaking, a unique record or tuple is possible for that given set of information, and it's a particular subset of the total amount of data that you want, like customers and orders and payment information, or auctions, bidders, and bids, which should ring a bell, right? You have this information and it's not duplicated except for some key fields, Okay, I just want to call that out. The key fields and the relationships between them become possible once you can associate those common links, right? So in the orders table, you're going to have a customer. You could have all that customer information, or you could just have a customer ID, right? Normalizing a database is saying, I want to structure the database. And it seems simple at first, but it's great to do on a whiteboard, and you'll find that you like redraw the structure of the tables 2 or 3 times. Now, if you take a little bit of time, I'm saying an hour or 2 to organize your information, you will reap years of amazing efficiency. If you wing it and you just start stuffing information in tables and then you stitch them together, you'll be sorry, and half the time it won't work right. So it's a subtle thing, but an important thing. Database normalization. Any questions? Any questions about normalization? COD used this abbreviation 1 Nancy Foxtrot, 1NF, to represent what he described as the first normal form of a table, where there are no duplicates and there is a unique key. And you see that as a repeating pattern. The fact that we can stitch tables together in Access means we've created those data sets and each of them has a unique key. There are no null values in a column field, right? So you can't have non-values in required fields. If the fields are required in order to make a relationship and you have no information in there, ooh, it breaks the database. So the default values often solve this problem. When you're setting up database tables, what you want to do is choose the option to put a default value in there to initialize the entry, so to speak, right? Now, we go to the trouble of explaining what a tuple is. And this is something you want to read when you're not in a hurry, but it's very plain, very straightforward, okay? So these are data sets with the same attribute, a values pair. So name John and name Jane are related. Those are part of the same tuple. If you have name John and you're comparing it with gender male, name and gender are 2 different criteria. I want to call that out. This statement sounds really complicated, but at the heart of it, we're saying if the criteria differ, well, then they're not 2 records or 2 tuples of the same data set, right? They're not 2 listings of the same data table. It's something else. So now you could have a table that lists the name of a person and their gender, but if you're going to be comparing records to records with a join, the important thing is that you're going to compare name where John's record is and name where Jane's record is. You're not going to compare through relational algebra trying to detect name John with some other person and you're pulling from the gender column, the gender field, right? Those are 2 totally different animals. And that's why it's considered a no-go, okay? So when you have that relationship between the 2 tables, you can kind of like hop, skip, and jump between the related values. That's what's going on there. And that's an oversimplification. Now, I do talk about some Greek letters in here. How many of you are members of sororities or fraternities? Anyone? Member of a sorority or fraternity? Okay,
Yeah.
Okay, that's good. I'm glad somebody in the audience is. Somebody in the audience has a Greek background. All right. COD used certain symbols, Greek symbols, to represent the types of relational operations. Now, in computer architecture, we talk about logical operations, and, or, and not. In mathematics, we talk about mathematical operations, multiplication and division. In relational algebra, we talk about operators that have the same kind of functionality. It just has to do with how the tables are related, all right? So they talk about the different symbols, and you need to be able to recognize the symbols and the name and the association with what it is. A restriction operator uses a lowercase sigma, a query with a filter for a given value. Okay, I want to look for all the males in the table. I want to look for all of the leatherback turtles. Restriction is a sigma operator when you say, hey, I want to search for all the leatherbacks in this table. That's an example of restriction. We're restricting the output of that query when the tables are related to only leatherback entries. Okay, so that's an example of restriction. Any question about this? All right, and then the rest of this, I can explain all this, but quite simply, it is pretty plain language. If you run into some, there is a picture in your book about union, intersection, and difference. You should look at the picture in the book on page 72. It's well worth your time. It'll show you the differences between those three diagrams. And in fact, pretty sure we had a picture somewhere. Do we or do we not have a picture? Oh, we have some diagrams. Look at the picture in the book. Any questions about this material before we close today? Different type of relational operators. That's called RA operators, relational algebra operators. It's a very fancy way of doing what? Doing the database, I'm sorry. It's a very fancy way of showing you the same thing here, where we're relating, we're running queries, we're using that same kind of algebra, right? And this is a lot friendlier and a lot more sensible. Some of this stuff starts to click once you start to use it and work with it. And then what I'd recommend is, oh yeah, go back and then read again that addendum. It's iterative. So you do the solution, then you go back and you're reading it and you're like, oh yeah, that makes sense. Now I know what they're talking about. Where if you just read it first and then don't, it's kind of fuzzy, right? Any questions before we close for the day?